There we go. The unmute. Kia ora koutou, ko Michael Howden, takurangawa. So my name is Michael Howden. I'm not a systems engineer, originally a studied as an engineer. Actually worked with Steve when he was back at Becker. So look, I'm really appreciate the opportunity to come here today and talk to you about some research that I've been doing sort of on and off for a couple of years. I've been working in the water sector for about 10 years now, and starting to get involved in this, I really sort of started getting really interested. My background's in digital, like how can we better measure this, model this, manage this? I thought, hey, could we build a digital twin of water in Aotearoa, New Zealand? I actually went back and did some study looking at systems thinking, looking at regulation, and sort of where I came across sort of the complex of the concept of complexity, which I'll sort of touch a bit on and presume you're all pretty familiar with that. Um, and this has sort of resulted in this research that I'm here sharing with you today. And I'm actually going to be sharing this at the Water New Zealand conference next week. So it's great to have the opportunity. Feel free to fire off any feedback. That'd be really appreciated. And hopefully we can have a bit of a discussion at the end of this. For my sins, I've also picked up a Complexity Fellow title from the University of Victoria University of Wellington. And I'll talk a bit about some of the activities I've been doing with that and opportunities for you to be involved, especially those of you who are in Wellington. So today, as I said, I'll go through a bit of a Complexity 101, give you a bit of an introduction to our water services system. I'll talk through the research methodology for this particular part of the research I've been doing, noting some of this builds on what I've did in my master's studies. From that, I'll talk about factors at play in our water services system. We'll touch on some of the feedback loops, but really, I think the main show is diving into the causal loop diagram. And I've prepared a bit of a tour to hopefully make it a little bit more accessible. I think from that, there's some key lessons for the water sector, and also lessons for complexity science. And I think for all of us as people, as systems thinkers, as systems engineers as well. And I'll share some of those links for how to get involved. So look, just starting off, I've got two pictures on the screen here, which really set the scene for the state of our water sector. The top picture is a picture of the borehole in Havelock North, which got contaminated and led to the Havelock North drinking water contamination event where 4 people died and thousands got sick. And that really led to a whole series of reforms. The bottom picture is one of our Wellington pipe bursts, a commentary on the state of our network and some of the challenges that we have faced here in Wellington around water shortages and just generally asset deterioration. So, look, talking about complex versus simple or complicated, I'm hoping this is a useful refresher, but I thought it would just be useful to sort of explain where I'm coming from when I talk about these different when I talk about complexity. So really, it's systems where there's a lot of difference within that system. You've got that non-linearity. You can't really determine. You can't predict what it's going to do. It's dynamic. It's always changing. Everything's connected within it. There's feedback loops at play. It's also adaptive and self-organizing with emergent behaviors. And I think we're going to see that at play in the water services system. I think one of the key things that makes this a complex system and one of the most interesting parts of really complex systems are people. And I think one of the insights that I have is how people will actually react to anything you try and understand about the system and lead to even more unpredictable behavior. So I'm just going to start with a bit of scene setting, and this is an example of a rich picture that I prepared in my master's thesis. So in my master's thesis, I looked at a variety of different systems thinking techniques and tested those with different regulatory practitioners. Rich pictures, effectively drawing a picture, it was the most accessible and actually the most sort of biggest bang for buck in terms of getting a group of anyone to sit down together with a flip chart and actually draw out the complex system that they're working in or they're trying to understand. So I've digitized this and it serves as a bit of a sort of a 101 for our water services system. So as you're probably aware, we all drink water. As I've talked earlier, if that's not healthy, some of us can get sick from drinking it. Sometimes that can kill us. Sometimes it's just an upset stomach, but most of the time it makes us happy. Most of us get our water from a water network connected to a water treatment plant, which is managed by an engineer and a range of different people who help keep our water supply reliable and safe through different treatment types. It's often someone managing that team, and typically those services are provided by councils at the moment, and we'll come back to that later. There have been a variety of different regulators, and this was actually a picture of the previous regulatory regime before Aotearoa, the Water Services Authority, came along. And whether or not that's a local council or a national regulator, you've got people who are voting for the representatives there and paying you the taxes or rates. Now, if someone dies, that's going to cause some attention. And sometimes, if water's unsafe, that will lead to a boil water notice. There's lots of different reporting that has to happen through the system. There's guidelines, there's funding which can be given, or regulatory actions. So really, I guess the key thing there's a lot to say here is that there's lots of different people at play, lots of different activities going on, different information flows. All of this is happening in the environment where there's actually different users of our water, which can impact the quality of it, and different regulators at play as well. Everyone has their own sort of thoughts, feelings, and opinions around how things are going, and sometimes these align and sometimes these don't align. But the one thing that we know is always going to be true is we're always going to need water, for the time being at least. So this hopefully sort of sets a bit of a landscape of the complex system of water services. And this is just a point in time, not even going into looking at the sort of the dynamic nature of the reforms. So what do these dynamic reforms look like? This sort of animation on mapped animation is just sort of showing what it was, what it is now, what the Labor government was proposing under Three Waters, and then sort of what we've ended up now under Local Water Done Well. For those of you not intimately involved in the sector, it's going to end up with about 40 different water services organisations and councils providing water services. A lot less than the 4 proposed by the Labor government, but a little less than the 60 odd that we have at the moment. Throughout this whole process, there's still problems, and I think this is going to be a bit of a journey around affordability, water quality, water quantity, and sector capacity. So that's really framing out the research. So how can we sort of apply some systems thinking, some complexity science to this to better understand this complex evolution by both looking back and looking forward? So the research methodology I followed is doing a literature scan, and this is not a full piece of research for a academic paper. This is really doing some research for a conference paper to try and get a better understanding, which I can share with people. I think probably from your perspectives, maybe not being water professionals, it's probably more about the methodology and how I've approached this and presented things, rather than necessarily the insights for water, although I'll share both. So for the literature scan, I've actually used a large language model. So just using Google Gemini, and I'll give you a bit of a peek under the hood about how that's worked. And I've then pulled out all of a lot of factors into Excel. I've then imported those into Kumu, and I'll show you what that looks like later. It's a tool for creating causal, well, actually any type of system maps. Some of you may be familiar with. I've then manually looked at the different connections, gone through the 80 odd factors and linked them up appropriately. Then I've been able to export that and review that back in the large language model. Once again, sort of iterating between the systems mapping tools, between using the large language model, and also falling back on my own sort of awareness and expertise in the water sector. Finally, I explored various feedback loops, and I'll show you some of those. And then I was actually able to review and narrate those by the large language model, which was quite interesting. But finally, the synthesis was really a combination of me writing and the large language model writing, but a lot of my own thinking going in there as well. So what did that actually look like? Sort of just, I think a lot of people talk about AI and it's something big and fancy. This is not a big fancy use of it. I discovered because of the linguistic nature of large language models, it's actually quite interesting to use it to interrogate large volumes of text. I've thrown in reports into ChatGPT previously, but also Gemini, and said, can you please create a causal loop diagram for me? And it actually creates the factors, the connections, and then it writes Python code to create the diagram, which was quite interesting. In this case, I actually exported it out into Kumu to just allow me to sort of play with that a little bit more. So that's what the prompt that I fed into it looked like. I actually had to chunk it for different time periods just to get a full, make sure it wasn't summarizing too much and get a range. And I did a lot of heavy lifting in Excel as well. But that's just giving you an example of how I used all of these to create this system map, which I will dive into in a bit of detail, and we'll touch on the sort of the complexity of the map itself. So just I can come back to this if there's interest, but I suspect this is probably some of the detail that's of more interest to water professionals. But these are the different factors that I extracted through the literature review. I categorize them under beliefs, financial factors, legal factors, communication factors, physical factors that are these properties of the real world, political factors, social, institutional, and then technical. Based on all these factors, and maybe I should have dived into the causal loop diagram first. These are the sort of feedback loops, both reinforcing and balancing, that I uncovered. So look, this is where I'm hoping I can just switch screens, or at least switch this over to this screen. Cool. To actually show you what this looks like. So your first impression is probably this is a giant ball of spaghetti, which is probably pretty accurate. And I think this is one of the questions that I continue to ask as we go through systems thinking, systems mapping, and potentially even systems engineering exercises. Are we creating shared understanding, or are we just creating a cool picture just for ourselves? And whether or not you're mapping out the evolution of water services in New Zealand, or in my world, a lot of time it's digital architectures. It's like, have we actually created a resource that creates shared understanding? One of the ways I think we can help with this, without sort of diminishing or taking away from the complexity that we want to understand, is layering it, or creating stories through which we can take people, like what I did with the rich picture before. So hopefully this is going to work. So look, in the diagram, I detected a number of different trends, and I'm not going to go through all of them now, but I'm going to highlight some of probably the two key ones. One is looking at drinking water contamination. So there's a number of factors at play, and immediately you can actually see it. So the diagram starts being a little bit more straightforward, but let's just really step through that step by step. So look, what we're seeing is a combination of extreme weather, which can actually, when there's flooding, impact infrastructure quality, but heavy rainfall and an unsecure bore. Basically, the concrete rim around the bore was not as robust as it should have been. So effectively, rainwater washed sheep poo into the bore in Havelock North. This led to contamination of drinking water. So drop in drinking water quality. As a result, there was illness, and as I said before, 4 people got sick, and 4 people died, and 5,500 people got sick. Now, this naturally caused concern and created political pressure. And when people die, it's quite a strong political pressure, and the regulatory space is quite often a bit of a sort of a strong and sometimes overreaction. Wouldn't necessarily say in this space, which led to new legislation and stronger regulation. As I said before, the establishment of Taumata Arawai, the Water Services Authority. This, I would say, increased risk management practices. Actual fact, I'd say it took a bit of time and probably another outbreak in Queenstown before Taumata Arawai really started putting its foot down and saying, look, water supplies need to have bacterial barriers, need to have protozoal barriers, and really insisted that those get put in place. And those have been put in place, and we're seeing a lift up in quality of our water supplies. And as a result of that, and this is driving that infrastructure investment. I don't have my sorry, Zoom up. So if there's questions, Steve, just holler out. And
yeah, sorry, Michael, I was just trying to find the mute button there. Yeah, no worries at all. We usually, I mean, happy to have questions throughout, but we usually just have questions at the end if that works for you.
totally fine.
Awesome.
So look, I think the water reforms are really interesting. So I think this comes down to like, can we afford and how can we afford the infrastructure we need? So infrastructure investment costs money. It increases the cost of water services. That goes into our rates. That rates going up and impacts affordability and it creates a public concern for the cost. So generally, sort of efficiency is a hard one to argue against, although we'll see how it gets a little bit complex. How do you achieve efficiency? Both sets of reforms have talked about the need for scale, standardization, and look, I've struggled with this word, but the best word I come up with is corporatization, more sophisticated, without diminishing the amazing work of water professionals across the country at the moment, but professional organizations that are dedicated to water services. I think when you've got water services that are buried in a council who are trying to do a plethora of other things, it's never going to get the same attention and prominence, and sometimes the attention it needs as a dedicated water services organization, like you see in Auckland with Watercare. So what's going to drive this? And there's different ways to do this. What the Labor government did with the Three Waters program is they promoted structural reforms, as has the national government, but they mandated that, so they required this. And look, I won't lie, I think there's a little bit of a dose of neoliberalism, like that mentality of actually having professional organizations rather than things being run by government bodies. And I'm going to try and sort of highlight these different beliefs without necessarily making any judgment on them. Having said which, of course, there's always going to be judgments involved. Looking there, sorry, and there was, to start with, there was public support. There was concern about cost, and with the second term of the Labor government, there was a lot of trust in central government. I think COVID is a big part of that. We had a government re-elected in a majority, and I think part of what happened with the Three Waters reform was actually a pushback from COVID as well and the lockdowns. But try not to add that whole different lens of complexity. But as I'm sure you all know, the Three Waters reform program was not without contention. I think one of the big pushbacks was around localism. People didn't want their water services taken off them by bureaucrats in Wellington. And so there was a lot of pushback. People were worried about the potential for privatization as a result of that. Some didn't like the idea of cross-subsidization, and even now we're talking about harmonization as water services merge. What if your region had been investing in your water supplies and managing them well? Did you want to have to pay for someone who's just built libraries and new council offices instead? So these factors start sort of adding up. Then we can start looking at co-governance, and that was one of the part of the Labour's policies. There was advocacy for Māori water rights and interests, Māori participation in water services. This led to more complicated structural changes, which were already complicated to start with. As a result, there was complex and often conflicting information. The government had a media campaign which didn't really land that well. A lot of people said, should the government be doing what felt to some like propaganda? As a result, we ended up with campaigning around this, advocacy campaigns against it, and a lot of misinformation flowing about as well. This confused and scared people, and I think this is a factor we need to look at. How does this impact people? As a result, the government lost their mandate. They were kicked out, and I think water was part of that. And we've ended up with a new government with a new set of reforms. A lot of these patterns are still at play. Some of them are not. Co-governance is not part of the picture anymore. I think one of the key things is consultation, and you'll see that pink box. You may have missed it. Just pick. appear down the bottom right corner. One of the differences between the reform from the Labour government and the reform from the national government is the national basically said, hey, councils, you figure it out. You figure out how you're going to do it. We'd like you to work with your neighbours. And they made that pretty clear. And I'm pretty sure there's been some private conversations to nudge people in the same right direction. But the councils had to go out to consultation. Every single council had to go out to consultation to their communities. And I think councils are a better place. They're close to our communities. They could consult on a region by region basis, on a sort of territorial authority by territorial authority basis. People could make submissions to with their own communities. I actually went up and gave a submission to the council officers just down the road from where I live, really. So you had that more consultative approach with it. But sort of even looking at where we are now, I think there's a question like, are we bringing people along? And I think one of the things that I think about is how are we growing public water literacy? Do people really appreciate what needs to be done? Are we creating transparency around the state of our water assets? I think a lot of noise about people not taking their assets off them. I question whether in some of those cases we're talking about assets or are we talking about liabilities? So look, that's me trying to sort of take you on a bit of a guided tour through a very complex system map. Hopefully that has provided some insights for you in both sort of our water services, but also like how to present some of these complex systems. So if that goes now, I can come back to that if there's any questions later. So look, reflecting on the water sector, like probably didn't really dive into too much, but at the start I showed through that feedback loop around if there's a contamination that can drive infrastructure investment. That's a really inefficient way to build infrastructure, waiting until something fails and then fixing it. How can we be more proactive, and how can we create some of those drivers to drive that proactive infrastructure investment? I talked about some of the reforms, but there's also drivers through economic regulation as well. I touched on public engagement as well and the importance of being able to clearly communicate to people the state of our water. I think there's a really interesting feedback loop around public engagement. People only care if something's going wrong, and once things are working, people don't really care. It's almost a sign of success that people just turn on water and take it for granted. But you actually need people informed so that the right decisions get made throughout for longevity. And finally, I didn't touch on the importance of capacity development. I talked about sort of lifting the professionalism of water organization. A lot of this comes down to good risk management practices and good asset management practices as well. There's a range of other reflections as well. I won't go into all of those, but in detail, but water metering ties into some of the shortage issues. Actually, water metering and user pays is one way to drive water literacy, because the best way to get people thinking about something is to give them a bill for it once a month. And then they're really realizing that they're actually paying for something. Better procurement processes, standardization of design. How can we get the best of localism at scale? Thinking about how do we align the market forces, and then some considerations around sort of Māori rights and interests for water, around celebrating some of our Indigenous knowledge, Mātauranga Māori, and supporting Māori water professionals so they're engaged in the process meaningfully, and supporting authentic treaty partnerships. Possibly of more relevance to this group is the reflections for complexity science, and I'd be interested to hear how sort of the community of systems engineers relates to complexity science as well. But I think in the processes, everything should be made as simple as possible, but no simpler. How can we actually make these systems maps accessible? I pulled out this Nietzsche quote: "Whoever fights monsters should see to it that in the process he does not become a monster. If you gaze long enough into the abyss gazes back into you." I certainly felt that as I was going through the process and developing the systems map. Is like, am I just shifting complexity from the real world onto a map, and is there actually value in this? But I think one of the things I realized, and the first time I went through this with a group, is realizing the map is not a story, and people relate to stories and people engage with stories. And so that's what I've tried to do today, is actually tell a bit of a story about a map. If you were just showing this, you'd be like, oh, cool piece of paper, what's going on there? But I'm sure many of you will realize this map is the basis of many a great story from Lord of the Rings and The Hobbit. I think a really interesting thing when it comes to complexity, and I've been reflecting on this quite a lot, a simple lie may trump the complex truth. And I think as we're dealing with more and more complexity in the world, it's important for us to not shy away from dealing with the complexity. Sometimes it's going to be contradictory. People will have different opinions that can be in conflict, but still both true to them, and sometimes objectively true as well. I think it's dangerous when we start just going with simple lies just because they're easier to understand. And lastly, just showing you sort of the next step of some of this work is how do you play with your system? And an approach that we're actually applying next week is we've actually built a serious game, and I'm not sure if you're familiar with that concept, but we've taken out a lot of looked at some. Actually, there's really I should have done a diagram. There's really only three interactions. You've got the condition of your asset, but assets, the how well you know about your assets, and then your asset management practices. And we've built a game out of those, which we're going to be playing at the Water New Zealand conference next week, really to emphasize the importance of having good asset management practices, good data as well. And that allows people to explore and have fun and sort of start to appreciate how some of these sort of systems dynamics come to play. So I've done a couple of test plays which have gone down pretty well, and I look forward to seeing how that lands at the conference next week. So look, just finishing off with a bit of a call to action, and Steve, hope you don't mind me plugging a conference that we're running next year as well. So the first is Cafe Complexity. So this is an event that I co-host with Victoria University of Wellington. It's once a month, so it's actually going to be on next Thursday. I won't be there, unfortunately. We've got someone talking about the complex systems around I think the Antarctica actually, and this is just a photo from one of the sessions we did around agent-based modeling a few months ago, sorry. So everyone's welcome to come along to that if you can, if you're in the city and you can get up for that time. And then secondly, we're running a Capital City Complex Systems Symposium in February next year. We've got a call for abstracts open at the moment. Probably going to extend it a bit. So if that sounds like something you're interested in, I'll just share the link in the chat if that's okay, Steve. And please reach out to me if you've got any questions, or just put an abstract in there. I think it's really interesting. Complex systems mean a lot of different things to different people. There's quite a sort of a group of academics who are doing a lot of work in that space. It's sort of coming from network science and systems thinking as well, but we're really trying to broaden it out and as it says on the title, go from theory to practice and impact. So I think some of you are probably in that space already, so it would be great to have your input into that symposium. That's it from me. I think I've probably just come shy of 20 minutes, so hopefully there's some food for thought. I'm really happy to take any questions, take any feedback, and yeah, discuss any of this further.
Thanks so much, Michael. Yeah, very, very well thought through presentation, and it's always great to see stories as well through data as opposed to just statistics as well. So thank you so much for taking us through it. One question I'm happy to start off is kind of, I guess, what's the end goal really for this sort of work? Is it, and who's the target audience? Is it the policies that you're looking to change, or is it actually trying to align, I guess, the understanding of why policies are being made and the current ones to then understand what needs to be done from a more of a delivery and management perspective?
Look, I think that's a great question, and I'm gonna come up and just be honest. Part of this is my own curiosity and like thinking, how do we understand this? How can I understand this better? I've got these tools, can they be applied? And so I think there's a risk in that. And so I'll be really upfront with that. I think if you're thinking about policies, a big part of that is like what's your span of control, and like there's no use trying to like map out a whole system where like, well, actually, there's limited use in mapping out a whole system where you've only got sort of a very small span of control, and maybe it's actually, instead of going wide, it's better to go deep into that specific area. But at any point you put a boundary around something, there's going to be externalities that you may or may not understand, that may or may not come and bite you in the ass later. So yeah, I think it's a communication tool as much as anything, and it's how do you have conversations? How do you have conversations with people and be aware of where there's actually other factors at play influencing how they're acting, how they're behaving? How do you actually get an appreciation for what's driving people? Are they acting? They may seem to be acting illogically, but there may just be other completely logical things at play in their worlds. And so it's actually being able to step back and have a better holistic understanding for the system.
Great, thanks, Michael. Got a few hands up, so I'll start with Jess.
Yeah, thank you, Michael. This is a great presentation. The grappling with and wrestling with complexity has been where I've spent much of my career. Not that the systems in particular themselves, the thing that's being designed, developed, deployed, is complex, but rather the projects that surround them, the human environment in which those decisions are made. That's where the intersection between policy and user need and like technical capability is, sometimes it's a very small space. Have you in this, this particular example of mapping out a very complex system to aid with understanding, brilliant and useful. And I love a diagram that has a lot of detail in it that allows you to really understand what's going on. Is there any mechanism that could you use a tool like this to look for ways to design complexity out of a system? That is, to make deliberate choices, implement deliberate choices to reduce the complexity of what is, of a system? That's my question.
That's a great question, Jess. And I think this is like designing complexity is an interesting factor, an interesting feature. And from my, I think we didn't cross paths too much when we were at Becca together, but like from my understanding of what systems engineers do, it's very much a design factor. And whereas I think about emergent complexity as well, I think by understanding what's causing complexity, you can work out whether those causes are whether those causes are emergent or deliberate. And you may look at, like, by looking at the whole map, you're saying like that thing there is creating a feedback loop that is an amplifying feedback loop that is not desirable. So we've put that thing in there for this purpose, but it's got these sort of 7 unintended consequences. Is it actually just simpler to take that thing away? So yes, I think you could, but it's sort of being mindful of, it's about looking for intended consequences and unintended consequences, and then being able to say, look, yeah, this meets this requirement, but it actually does these 7 things. And by doing those 7 things, yeah, those 7 things are worse than the requirement it meets. Does that make sense, Jess? The other thing, and just one thing I always think about, is one of the aha penny drop moments was when a lecturer said, look, like, and I was just saying, why can't we model the water system? He's like, look, it's the difference between a frog and an airplane. And an airplane is complicated, but a frog is complex. And I think there is some truth to that in your comment about the systems are maybe not complex until you add people into it. And I think the great example there is Boeing 737 MAX, which I'm sure many of you know in much more detail than I, the issue where the autopilot started interacting in a complex way, and the interface between the pilots, the training, and the regulation caused a complex emergent behavior that caused planes to drop out of the sky, which I think is fascinating.
Thanks, Jess, for that question. Over to John.
Thanks, Michael. It was an excellent presentation. Really great to see like a clear presentation of the work you've been doing. I feel like I asked a similar question last time we had a presentation looking at causal loop diagrams, but I'll ask it again, because I think the way you presented the story there is really compelling. But I guess to some extent that story is what's driving the construction of the causal loop diagram. So my question is, have you done anything, or can anything be done to verify the correctness of the causal loop diagram if you're going to be relying on it for making, planning or policy sorts of decisions? Is there any way to look at its predictive power and confirm that those relationships actually are correct, or anything like that?
Look, great question. I would be very apprehensive about saying it has any predictive power to it. I think it is descriptive only, and to try and use it to predict is a risky proposition given the complexity involved. I would like to think that using the large language model has added some of that. It's an objective. I've taken out the data behind it, so you can extract all of that data and say, verify this for me. I have asked Gemini, am I missing any connections into this? Now, I think I could have done that in a much more rigorous process, and that was part of my curiosity. And one of my colleagues at the university has actually been working on it, so you can actually dump. He's got a script, and you can dump any topic. He takes a news headline, it searches academic insights, and actually automatically produces a causal loop diagram. So how can we use technology to rapidly, and I'm going to say objectively, or at least with the bias of AI as opposed to a bias of a person, produce these causal loop diagrams? So yeah, there's the other approach is to do this as a group, and to do this through a group process to discover these things. If I'd had more time, more resources, it would have been great to actually print this out at sort of a naught and actually get people to look through it, or actually get people to build it up themselves.
Great, thanks. I guess my sort of concern around the fact that it's an explanatory tool more than a predictive tool, which I agree with your sort of comment on, is that what's its value then beyond explaining things that you already know because you've used them to build it? I guess explaining to others what you already know is clearly part of it, but I guess sort of lingering concern around reliance on these things that are built according to your own, or the creators or the media's biases or interpretation of events that may or may not be correct.
I think it's one of the, like, when we talk about things there's things in your head, and then there's things on paper, and by actually, or physical artifacts of knowledge. And by having a physical artifact of knowledge, someone can point to a connection and say, that's wrong. And it's all down there on paper. And so you can actually contest that together and redraw it together. And so I think actually having that knowledge in a digestible physical format is actually quite valuable to develop that shared understanding.
Yeah, good answer. Thanks.
Thanks, John. Over to Tom.
Thanks heaps, Michael. That's really cool. When you use the large language model to first help describe the nodes, did you play around with just trying different numbers. So I assume you get sort of like a bit of convergence where if you add another node, you don't really get much more insight. Like you must sort of get a diminishing set of returns, and you're just adding a bit of complexity unnecessarily.
How do you mean different numbers?
So I think you said you might have had 50, asked it to create
Oh,
50
yeah.
nodes.
Sorry, I see what you mean. Yes, it's more about it was more about what it would like. It wouldn't pay attention to, like sometimes it wouldn't pay attention to that. I'd have to go back to my notes. I think like I settled on Gemini. I was using Copilot as well. I actually had three of them side by side, and so it was just to try and actually get it to get more. I didn't actually know. I didn't experiment to say give me 500. Which I could have, but it's also like there is a bottleneck there in my mental ability to actually process. If I'd come up with 5,000, it would have just been a bit overwhelming for me to do and like for me to present. Even actually after producing this and developing the story, I actually compiled a couple of things together because I'm just like, oh, do you need to know difference infrastructure quality for stormwater, wastewater, and drinking water? For the story, probably not. And there I've made a subjective decision, which I didn't go back and verify. So like it's there's more rigor could be added to it, but this is very much sort of an exploratory approach.
Yeah, it'd be kind of interesting to see if you can tell as good a stories if you say had 10 nodes. So it's like a much simpler sort of representation.
Yeah, I mean, it would be fascinating to actually do a complete end-to-end study where you actually did sort of like 10 nodes, like 5 nodes, 10 nodes, 20 nodes, 100 nodes, and like actually like what's more understanding is like where's the trade-off between detail and simplicity.
Yeah. Cool, thank you. Just thought I'd throw in an easy question.
Thanks, Tom. All right, over to the chat now. So we've just got a question from Danush. So Danush is asking, does New Zealand have a framework in place where it is easier to govern the policies, influence investments, and prioritize?
Oh, it's a political question. I mean, 3 things there: govern the policy, influence the investments, and prioritize. I think, I mean, yes, we have a framework in place to govern policies at the high level. I mean, that's Parliament and Cabinet. So that's the legislative process from a policy perspective. I think influencing investments, I think that's where regulation comes in. And so we're seeing that, we saw that out of Tamata Arawai, where they basically said, you've got to have water systems that comply with the regulation. You had, and for decades that hadn't been the case. So that's one way you can influence investment. And now we've got economic regulation coming in where they'll be saying, look, you've got to be spending this much to maintain your assets. If you've got $100 billion worth of assets and they've got a 10-year life, you should be spending $10 billion a year on your assets, for example. So and that there's regulatory models around that. Yeah, but I think we do have a process, especially with local government, is very much a decentralized control, and so that's not entirely centralized, and for better or worse.
Cool, thanks, Michael. And another question from Danush is just around the causal loop. From Danush, your causal loop work is very good. As part of your mapping, did you progress with what links are enablers and inhibitors? And did you analyze it further with any system dynamics modeling?
Yes, I did. So let me just pull that back over. So yeah, so actually I probably just didn't actually highlight that as much as I did. So the dotted lines are all negative, while the solid lines are all positive. And I can actually share a link to this as well. I might just do that there if people want to. I probably should have done that earlier. If people want to give it a kick and give me any feedback. In terms of systems dynamic modeling, no. I had hoped to. I thought about doing some agent-based modeling, but just, yeah, beyond the scope of this research.
Cool. Thanks, Michael. I'm definitely gonna have a bit of a play around with that, because I guess that's the interesting thing is you can almost tell whatever story that you want starting from anywhere and finishing anywhere, and yeah, it's quite interesting.
Yeah, and it was interesting sort of playing around with the functionality of Kumu to actually sort of annotate that a bit and animate that, I guess.
Yeah, 100%. And I think me probably going into engineering mode was I was thinking, how can you do like a sensitivity analysis? So you start looking at how strong the relationships are between the different nodes. But I completely agree with your frog analogy, you know, in an airplane analogy, and the determinism of this. And it completely depends on, I guess, so many factors that, you know, the sensitivity, how accurate could you actually make that? And what factors do you need to consider to think of the range of sensitivities depending on situations?
Yeah, but I think on the flip side of it, if we just say it's all unpredictable, it's non-deterministic, like there's nothing we can do. And I think this is the role for complexity, is we need to let go. Like we can't predict like deterministically, but we can predict statistically. We can say, look, I know this is where I come to consultation. Consultation probably is never going to be a bad thing. And do I come at that with sort of my own value systems? Yeah, probably. But yeah, we could probably, and I think that would be the really interesting thing. Geez, that's a freaking mess when we look at like that. Is like, what are the things where there's absolutely no regrets at this stage? Like, just like if we want water, we're going to have to invest in our assets. Like, let's just get on and build some assets. That's going to be a no regrets option. And I think you can actually probably start picking some of those things out.
Yeah, 100%. We may have time just for one more if there's any other.
Can I ask a question to the group then?
Yeah, 100%.
And
Yeah.
I think it was John who asked the question, and maybe this is a really bad place to actually have the screen, but as I went through that, was it understandable enough, or did you feel lost in spaghetti? And I'll welcome any comments in the chat.
Maybe for me, I would be like, I mean, if you could like, you know, in the causal loop methodology, we go through one loop and, you know, you've got those other loops. So you put in the loop numbering sequence so that you could follow. That helps.
Yeah.
I know, but then this looks really good in terms. I know Kumu is very nice in this space.
Yeah.
So like you follow that one loop and then you've got the other one, how that links to another one. Like you've got water where you've got like maybe sources of water where you're using, and then you've got policy in one loop, and you've got this like a separate, and then.
Yeah, one of the challenges is like multiple loops, multiple interconnecting loops, and crossing between policy and physical systems as well.
Definitely.
My thought on that is, I think there's a potential risk, and I think John brushed on it, is, you know, if you just gave someone this map without any kind of dynamic interaction, then yeah, you know, it's very, very difficult. But the dynamic interaction that you've shown us is really powerful, but it's telling the story that I guess the presenter wants to tell. And so maybe having the ability, like you've done, right, you've given us the actual access to this map, and enabling people to almost kind of come up with their own stories prior to then kind of having conversations might help drive, well, actually, are the things that we're missing? What are the common themes that are kind of coming out of it?
I think it would be interesting to actually hear the stories, and I think that would be a secondary piece, is like, where is the narrative actually, where does it not align with the map, and where do we need to add extra connections and factors?
Yeah, 100%.
Have you tried to validate or something with like the actual some one of those instances of events that you spoke of, like whether this is reflecting what?
No, I haven't, and that was one
that way. Maybe that would be one of those things which will inform you much.
Yeah, I probably need to add my next steps, future work. options to
Sure,
this.
don't stop at this. This is really good. So
Thank you.
Is there
Or-
any sort of narrative around the nature of each of those interfaces? Because I'm trying to have a little play around on the website. Is there anything that sort of says what each line kind of means?
No,
Or how it's affecting the thing that it's kind of connecting to?
no. I do have, and in my paper, and this is still a work in progress. I will add descriptions to each of the factors. And actually, this is something where a large language model helped me, because you can throw a list in and say, come up with a list of descriptions and then just edit them. But actually describing each of the connections is something that a large language model could probably help with a human in the loop as well.
Cool.
All right, we are on the hour, so very mindful of everyone's time. So I think we'll that's all we've got time for today. I'd love to continue the conversation. I think we could probably talk for hours on this, which shows how interesting the topic is. So thanks so much, Michael, for coming along and presenting this, and thanks for everyone for attending and having a great conversation. So yeah, looking forward to hearing more about the progress on this, Michael, and hopefully we'll have a bit more discussion in the future when you get it progressed.
Thanks, Steve. Happy to come back again.
Thanks very much. Take care.
Ka kite.